Now we'll calculate moment of inertia of a thin rod about an axis passing through its center and perpendicular to its length. Again, in this situation, we first need to consider an element, and as the rod is thin at a distance x from center, we consider an elemental point mass which is of width dx. We just calculate the mass of this element. We can write mass of element dm to be equals to m by L dx, as the whole mass of this rod is uniformly distributed in the length of this rod. So for the length L, if its mass is m, for the element of width dx, its mass can be written as m by L dx. And when the rod will rotate, this dm will revolve in a circle of radius x. So we can simply write moment of inertia of elemental mass is this di, we can write as dmx square. If we substitute the value of dm, it is m by L x square dx. And moment of inertia of rod we can calculate by integrating this di, which is integration of m by L x square dx. M by L is a constant, so we'll integrate x square. And when we put limits of integration, it will be for x, which is integrated from left hand to right hand. So it will be substituted as minus L by 2 to plus L by 2. So its integration is m by L. Integration is x cube by 3, and we put limits from minus L by 2 to plus L by 2. So this can be written as m by 3L into L cube by 8 minus L square by 8 will be plus L cube by 8. This will be L square by 4. So result can be written as 1 by 12 ml square. Similarly, we can find out moment of inertia of the thin rod about an axis of rotation which passes through one end of the rod. So if we rotate the rod about this axis of rotation, the moment of inertia will obviously be different. The length of this rod is L, and if its mass is m. To calculate its moment of inertia, we consider again an element of width dx from the axis of rotation, and elemental mass can be given as directly, which we have already calculated in the previous case, which is m by L dx, as the mass is uniformly distributed in the rod. And again, moment of inertia of element is, this can be written as di as dmx square, which is m by L x square dx. So we can write moment of inertia of rod about side axis of rotation is, the previous case, the axis of rotation was passing through center, and at the side axis of rotation, this can be written as integration of di, which is integration of m by L x square dx. But the limits of integration will change, as here x is varying from 0 to L. So when we integrate this, m by L is a constant, integration of x square is x cube by 3, and we substitute limits from 0 to L. So it will be L cube by 3 minus 0. So result will be getting as 1 by 3 ml square. So be careful about this result also. And always remember that for a given rod, if it is rotating about its central axis of rotation, its moment of inertia is given as 1 by 12 ml square. And about the side axis, it is given as 1 by 3 ml square. So both the results you need to keep on your tips for various kind of applications and problems.